I haven't yet shown the Paris Agreement, but I think you can imagine that if countries like India and China, for example, have committed to reducing their emissions by increasing their forest cover. So you go around planting trees, make your forests bigger and thicker, and promise to extract certain amount of carbon dioxide. Right? So terrestrial afforestation or reduced deforestation is a part of the solution. Can the oceans provide a similar solution? It turns out that ocean carbon in the coastal oceans, ocean forests, mangroves, wetlands, salt marshes can take down 3 to 10 times more carbon than land forests. That carbon in the water is called blue carbon, just a nomenclature, but it's evocative. Blue carbon in the ocean makes sense, right? So here are the ecosystem services per hectare. Ecosystem services is a terminology which tries to put a value on what you get out of an ecosystem. Difficult concept, not easily acceptable in the sense, let's say you have a tree in your backyard. You love the tree, right? It gives you shade, it gives you a place to sit and enjoy. It's nature you like, makes you feel calmer. But what is its value? How do you put a value on this tree? That's not easy, right? If you cut it down and make furniture, you can say how much it contributes to GDP, but if it's just standing there, what is it doing? So ecosystem services are not easily defined. Nonetheless, you can look at it as its ability to take out carbon, its ability to filter the water, its ability to damp the hurricanes and cyclones that come in, its ability to produce oxygen and provide habitats for fish and other creatures, and just the natural beauty. Right? So some estimates are made in terms of US dollars for the tidal marsh, for mangroves, for seagrasses, coastal planktons, and deep sea, and so on. These are called ecosystem services. There are also estimates of terrestrial ecosystems, but you can more specifically look at gains and losses of blue carbon stocks with a range of climate change factors. I won't go through all the details, but you can look at the table at your own leisure. We are again looking at ecosystems: mangroves, tidal marsh, seagrass, and seaweed. We are looking at the impact on sea level rise, extreme storms, higher temperatures, extra CO2, and altered precipitation. So, for example, if you take mangroves, landward expansion of increases in area and carbon stocks, increasing accommodation space for increasing carbon sequestration. That's what sea level rise would do for mangroves. If sea level rises and provides you more brackish water in which mangroves live, then obviously you can have mangroves expanding seaward and taking up more carbon. They're much more efficient than land forests in taking up carbon. I don't know if the birds are making a lot of noise that is getting recorded, but let's hope not. Increasing accommodation space increases carbon sequestration, obviously, and soil elevation gains happen due to sediment deposition, increasing carbon stocks and reducing the effects of sea level rise. Okay, that's from for in terms of extreme storms and so on. Okay, so these are the kind of ecosystem services that can be easily shown, demonstrated, but how to monetize it or how to put a value on it is not always easy. So this is another table that tries to put all these things together: ecosystem services. So you have ecosystem species, structures, and processes. Water chemistry, secondary production, evolution and species diversity, primary production, habitat construction, oxygen, 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 plus nutrients. Okay, this really makes a big difference. Soil formation, sediments come in, they convert it into soil by these coastal ecosystems, and wave modification. Of course, they are very good wave dampers. Okay, so in each direction there are many things. So fish production, for example, fish, shellfish, algae, birds come in, various animals come in, even dolphins come into mangrove forests, sharks come into mangrove forests, Bengal tigers come into mangrove forests, and so on and so forth. So this is a program called Living with the Ocean under the Circle of Sustainability. Talks about marine resources, how it serves man and society in terms of food, ecotourism, medicines, uh, good for health, and so on, and what our impacts are on the marine ecosystems, and what are the threats in terms of various factors that are natural as well as man-made, or natural threats amplified by the human being. For example, sediment loading is a certain amount, but if we uh, convert it to agricultural land from forests, or we urbanize, then we increase the runoff for the same amount of rain, we increase the sediment loads, we increase the nutrient loads. So a natural process is heavily converted and made into a threat by human beings. So this is a nice figure that's showing a coastal forest with the water here showing all kinds of life. Marine biodiversity, again, biodiversity is not easily defined. Everybody intuitively knows what it means, but you can define things like health of a system, for example, how productive it is, how resilient it is, which means if you perturb it with a heat wave or a tsunami or a hurricane, how quickly it recovers, and how complex it is, or how many species are there in a given region. So health of the ecosystem can be complexity, resilience, and productivity. So there are many such measures that can be used. Ultimately, it obviously comes down to convincing people to reduce their footprints on the ecosystems. That goes back to behavioral aspects. Some people are more amenable to trying things. Some people are not. Some people say, I don't care. So it's always a struggle.